All right, so for the past few weeks, we've been on a journey, right? We've been gathering all these puzzle pieces. We explored the AI landscape, we engineered some pretty cool agentic workflows, and we figured out how to ground our models in reality. Well, today is the day. We're putting it all together. We are going to architect a complete sovereign AI system, and we're going to do it right here on Google Cloud. And honestly, that quote is the key to everything we're about to talk about. We've really moved past the idea of just having a single big model. Now, it's all about designing and building an entire ecosystem of intelligence. It's not about who has the smartest model anymore. It's about who can architect the smartest system. So let's start from the ground up. You know, every great mind needs a powerful body to back it up. And for our AI, that body is its compute infrastructure. This is the raw power. We're talking the muscle and the skeleton that's going to allow it to think and learn at a scale that's, well, truly massive. So right away, you're faced with a really key strategic choice. On one side, you've got TPUs. These are Google's own custom chips, and they are optimized for hyper-efficient training. On the other side, you've got GPUs, kind of the versatile workhorses for actually serving predictions out in the wild. But here's the beautiful part about the Google Cloud architecture. You don't have to choose. You can train on TPUs to save a ton of time and money, and then turn around and serve your model on GPUs for flexible, widespread use. You really do get the best of both worlds. But think about it. Having all that incredible processing power is completely useless if it's just sitting there, starved for data. These accelerators, they're incredibly hungry. You absolutely need a way to feed them massive data sets at lightning speed just to keep them working. And this is its high-octane fuel line. Managed Lustre is a high-performance file system built for one single purpose: feeding data to those hungry processors. I mean, look at these numbers. We're talking sub-millisecond latency and throughput of up to a terabyte per second. This basically guarantees that your expensive hardware is never sitting around waiting for data, which in turn drastically cuts down your training time and your overall cost. Okay, so we've got the power. Now we need the system to actually control it. This is the nervous system of our AI. It's the automated backbone that manages its entire life cycle, from learning and healing all the way to deployment, and it does it all without needing a human to constantly step in. And it's so important to get this. MLOps isn't just a tool you buy, it's a whole philosophy. It's about building a robust, automated platform from end to end. This is what gives your AI system that production-grade reliability, allowing it to learn, adapt, and improve, all continuously and automatically. And this right here is what that process looks like. You see, it starts with data, moves to training, evaluation, and then deployment. But, and this is the important part, it's not a straight line. The key is that feedback loop. The monitoring step might trigger a whole new retraining job with fresh data, which kicks off the entire automated pipeline all over again. Your model never ever goes stale. So how is this whole loop managed? Well, you can think of Vertex AI pipelines as the central orchestrator, the conductor of this really complex symphony. It defines and automates the entire workflow, connecting services like Cloud Build for continuous integration and Cloud Monitoring for, well, continuous monitoring. This is the automated brain of the whole operation. Okay, so we have power, and we have an automated nervous system. But for an AI to be truly useful, its intelligence has to be connected to the real world, right? It needs to be grounded and factual, up-to-the-minute information. And this is one of the biggest challenges in AI today. How do you stop a model from hallucinating, just making stuff up? How can you be sure that its answers are based on authoritative, real-world knowledge, and not just some weird patterns it found in its training data? Well, the solution is a technique called Retrieval Augmented Generation, or RAG for short. The best way to think about it is like giving the AI a perfect, searchable long-term memory. Before it even tries to answer a question, the system first goes and retrieves relevant facts from a knowledge base that you trust. It then stuffs those facts right into the prompt. This grounds the model, basically forcing its response to be based on reality. And of course, Google Cloud gives you an entire toolkit to build this at a planetary scale. I mean, depending on what you need, you can use the raw power of Vertex AI vector search, the convenience of AlloDB, the total flexibility of GKE, or even build a super sophisticated knowledge graph with Spanner Graph. The point is, you can architect the exact grounding system your application needs, no compromises. So far, we've built an AI that can think, it can learn, and it can access knowledge. But the final, really exciting step in its evolution is giving it the ability to actually do things, to reason, to plan, and to execute multi-step tasks to achieve a goal. This is what we call its agentic will. This represents a fundamental shift in thinking. Predictive AI is passive. It just tells you what it knows. Agentic AI is active. It doesn't just answer your question. It tries to figure out your intent. It breaks down the problem. It uses tools, and it takes action to get the job done. It moves from just answering what is to answering what should be done. An agentic system, it often works just like a team of experts. You'll have a coordinator agent, which is kind of like the project manager. It gets a complex request. It then delegates all the subtasks to specialized agents. Maybe one is an expert in data analysis, another one is a whiz at database queries. And these agents use tools to perform their tasks, all built on a common framework like the Agent Development Kit. And with that, all the pieces are assembled. We have the power core, the automated nervous system, the grounded mind, and now the agentic will. We've moved way beyond a simple model to a truly sovereign, autonomous system. The mind is now live. But with this kind of immense power comes, you guessed it, immense responsibility. Building the system is really only half the battle. Now, we have to learn how to command it, how to monitor and guide it effectively and reliably. So a key lesson for anyone operating these systems comes from the world of site reliability engineering. You have to focus on the 4 golden signals. Think of them as the vital signs for your AI. You have to monitor latency, traffic, errors, and saturation. These 4 metrics will tell you pretty much everything you need to know about the health and performance of your entire system. And all of these principles, everything from performance and reliability to cost optimization and security, they're all wrapped up in the Google Cloud Well-Architected Framework. It's basically the blueprint for building robust, efficient, and reliable systems, and it ensures your creation is built on a solid foundation of best practices. Look, this isn't science fiction anymore. By putting together these architectural components, the specialized hardware, the automated MLOps, the planetary scale RAG, and these multi-agent systems, we have truly, genuinely entered a new era. The era of autonomous execution has begun. So we've shown you the architecture, the components, and the principles. We've mapped out the entire landscape. The technology is here, today. And so now the only question left is the one that matters most. How will you command it?